monitor those.
Yeah. Will that stop it for, or do we have to check?
It'll stop, but it may be too late. I don't know. I haven't adjusted anything in a while.
I'll check in.
Okay, matrices. What is a matrix? Matrix is a way to organize information. It is described by having rows and columns of information. And in those rows and columns, you would put numbers, and those numbers would represent different things. They can represent equations. And so it's just a different way to organize information that can be helpful for solving equations that are usually equations that are containing 3 variables, and you have a system of equations containing 3 variables. So we're going to learn a bunch of stuff about matrices. So this is 16.1. We typically throw these in there after 12, because 12 is kind of a burden of that chapter. So we jump into 16. Matrices, usually fairly straightforward. You can figure out how to do most of this stuff on calculators, graphing calculators, or some of the Casios and the Texas Instruments. But I'll require work of longhand, so to show how you solve this longhand. You can confirm it with the calculator, but everything will be done longhand. So I won't show you how to use the calculator, but you can figure it out if you want to check information, but you have to show your steps longhand. So a matrix is defined by rows by columns. So if I have the letter A, we'll call it matrix A, capital letter, describes a matrix. And if I said matrix A is a 3 by 2, okay, that means it has 3 rows and 2 columns. And it's defined by having brackets like this, and it looks something like this. Now, in each individual, or in the matrices, there's what we call elements. And so I'm going to make up some numbers like 5 and 0, -1/2, 2, 4, and 3/7. And so there's your matrix. That's what a matrix looks like. And it has, again, described by how many rows and columns it has. So this is a 3 by 2. It goes rows by columns. So this is 3 rows, 1, 2, and 3. Columns 1 and 2. Okay. So that would be a general looking matrix. A square matrix would be, if you had a square matrix B, a square matrix would be like a 2 by 2, right? Or a square matrix would be a 3 by 3, or 4 by 4, 5 by 5, so on and so forth. Those are square matrices. The 0 matrix, they'll probably use a capital O, and then they'll call it a 0 matrix. Doesn't have to be square. It could be a 2 by 3, let's say. The 0 matrix just means it has 0 in all of the elements. So the 0 matrix, if it was a 2 by 3, that means it has 2 rows, 3 columns, so like that, 2 rows, 3 columns, and that would be a 0 matrix, where 0 is in everything. Okay, so there's a little bit of terminology. We talked about these are called elements. This is an element, this is an element, element, element. Other things that we should make a note of. Let's just do a couple examples. How about that? Find the value of each variable. So number 1 here, if you have something that looks like this. So if it is the letter O, like that, it is referring to which matrix? Always going to be referring to your 0 matrix, okay? Other matrices may have the letter A or something like that, but if it's like this, you know it's referring to the 0 matrix. So in this case, though, they have this matrix right here, and then they plug in this, and this, and this, and this, and this, okay? So what they want you to do is they want you to look at the 0 matrix of 3 by 2, has 3 rows, 2 columns, all those elements in there. And they want you to figure out what is the value of x equals something, y equals something, and z is equal to something, okay? Well, what does x equal?
0.
Yeah, 0. What does y equal?
0.
0. And what does z equal?
0.
0. Yeah, so this one's very straightforward. They're just saying, hey, 0 matrix, every element is going to be 0, so we solved for it that way. Okay, what happens when you have a matrix? It doesn't have a name to it. It's just a matrix written equal to another matrix. Now, in this case, remember the dimensions. How would I describe the dimensions of this matrix? Is it a 1 by 3 or a 3 by 1?
1 by 3.
1 by 3, because remember it goes what? Rows by columns. So it has 1 row and how many columns? 3 columns. So a 1 by 3 matrix, you don't have to write it down below 1 by 3. I just want to write a 1 by 3. A 1 by 3 equals, do you think a 1 by 3 could equal a 2 by 2? No, a 1 by 3 has to equal a 1 by 3. And so then they give you this, y, 4, and 0. And now we need to solve for x and we need to solve for y. So in this case, it's just matching the elements, right? So what would x equal? 4, and then y equals 2. Okay, pretty straightforward on these ones. Now if you just have a full class in there.
Now I'm gonna get a full class. Why?
Okay, so when you go to solve these, you just set the elements equal to each other, right? So it's a 2 by 2 equaling a 2 by 2. So you're going to take row 1, column 1, and then match that to row 1, column 1. So you would just say, okay, 8 minus y equals negative 3y, and then you just solve for that. So you get 2y is equal to negative 8, y equals negative 4. Okay, on the next set, we look, we say, okay, I have x plus 2z is equal to negative 5, right? So that row 2, column 1 equals row 2, column 1. With that being said, is that an issue? Well, sure, because how many variables do I have? 2. But, can we set up another equation? X plus z is equal to negative 1. Absolutely. 2 equations, 2 unknowns. This is what we call a system of
Linear equations.
linear equations. And what do I do with those? You can subtract x's, right? You can do substitution. So if I was to subtract the x's, what do you have to do to, like if I go, oh, minus, it's not just subtracting the x, right? It's subtracting the whole thing. So the x's cancel, this becomes a negative, this becomes a positive, so you get z is equal to a negative 4. Sounds right. And then you plug in negative 4, and what do you get for x? X is equal to?
3.
3. Good. Okay. So then you're going to have one like this. So your last one, ax plus y. And then bx plus y. Wow, that smells so good.
You should enjoy one too.
Oh,
It's quite nice.
1 and 0. Okay, now in this case, they want you to solve for x and y. It looks a little bit more challenging because of the a and the b, but either it's the same thing. You just need x equaling something and y equaling something, except in this case over here it equaled numerical values. Here it's going to equal a variable expression because you can't get rid of the a's and the b's. The a and the b are going to stay, so it'll be x in terms of a and b, y in terms of a and b. So we set up a system of equations the same way. X is equal to 1, and then bx plus y is equal to 0. And then we go ahead and solve. What could we do to solve? A couple different rounds, but
Set like top two equal or solve for y.
so the top two equal.
Ax plus y equals 1.
Mm-hmm.
And then solve for y. Oh, whoops. Okay, so subtract. Oh, then you could minus ax. So y equals 1 minus a.
What?
Minus y.
Just subtract them.
You're doing substitution, which is valid.
Oh,
Same
okay.
thing. Now here in this case, if the coefficients don't match, right, it's ax minus bx. The y's cancel is equal to 1 minus 0 is 1, right?
Oh, okay.
But here the issue, this is a common, like, oh, I don't know what to do. How do I solve for x? Because they don't combine, right? It's not like, oh, if only it
Take
was,
x out.
yeah, you just factor the x out.
Oh.
Yeah, so the x comes out, it's just a minus b is equal to 1. Now what does x equal? Well, divide both sides by a minus b. Now in the book answer, they're going to say like this. Why do they attack that a can't equal b on there?
Because it'd be 0.
It'd be 0 in the denominator, right? So that's why they attack that on. If you don't put the restriction on there, I'm not going to mark you wrong.
Is that an energy tree?
No, it's a Zevia ginger ale.
Oh. I was like, man, you're really getting desperate if that's an energy tree.
I'm really going for it. So now, what does y equal?
Oh.
Oh. Well, I know what x equals, right? What does x equal? 1 over a minus b. So you can plug that into, it doesn't matter. Let's plug it into here, bx plus y. So we're going to say b times 1 over a minus b, right? Plus y is equal to 0. So then subtract this over, y is equal to a negative b over a minus b. There you go. And it's b over a minus b, and then subtract that from both sides. Okay? And that is it. So, I'll get homework assignment sheets are not printed yet. Page 769. And we will, you want the easy way or the hard way?
What? Who's that?
I don't know. Junior higher.
Yeah, it's in 7th grade, I think.
You 7th grade? And you 7th grade.
Oh. The tall guy?
Who?
The tall guy? Yeah.
Do you know him?
No. I knew of him.
You've heard of him.
What's the easy and hard way? Or
The easy way is, let me just check here.
The easy way is to not do it.
That's the easy way.
That's the Grayson way.
That's the Grayson way. What is the? That's the Grayson way.
That's really sad.
That's what you're usually down for.
Don't know if that's what I wanted to do.
It isn't, but life is hard. Numbers 1 through 21 odd. We'll give you the easy way. Okay. Probably get it done in class here. That way you'll have plenty of time to go on hikes this weekend.